So I'm going to start to go through exercise 1. Okay, so for the first one, you just want to find the zeros of f of x is equal to x squared minus 5x plus 6. So what is this going to end up factoring into? Yeah, exactly. So this is just going to end up being equal to x minus 2 times x minus 3. Just from the fact that we have that minus 2 plus minus 3 is equal to minus 5. Then we have that minus 2 times minus 3 is going to be equal to 6. So this means that the zeros are just going to be where these two linear forms are equal to 0. So this means that we're going to have that the zeros are just going to be x is equal to 2, and then x is equal to 3. And that's all there is to it. Okay, and then for B, B is like another one that's similar to, I guess, example 5 that we just did. So the first thing I'm going to do for B is I'm just going to factor out a 3. Like each of these coefficients are divisible by 3, so you can factor out a 3 to make life easier. So this is going to be 3 times 4x squared plus 4x, and then that's going to be minus 3 at the end. And so just as we did before, you want to think in terms of what numbers are going to multiply into the product of 4 and minus 3, so the coefficient of x squared and then the constant. So this is minus 12. And so we can just note, so like two numbers that are going to end up working here are going to end up being, so you just kind of note that if you do 6 times negative 2, this is going to end up being equal to negative 12. And then if you add 6 and negative 2, this is going to end up being equal to 4. So maybe I should color code this. So minus 12, we need these two numbers to multiply into. And then we needed them to add into 4 as it's the coefficient of x. Just as we were doing in example 5 pretty much. And so with this in mind, we can rewrite q of x as being equal to 3. Then we have 4x squared. And so we're just writing or rewriting 4x as 6x minus 2x, like the two numbers we found that multiply into negative 12, then add into 4. So this is going to be plus 6x minus 2x, and then we have a minus 3 at the end. And so again, just doing like the group factoring thing, we can factor out a 2x from like these first two terms. So this is going to be equal to 3, and then you factor out the 2x, so we have 3 times 2x plus 3, and that's going to be minus 2x plus 3. So this 2 times 2x plus 3 corresponds to the 4x squared plus 6x, just factoring out a 2x. Then the minus 2x minus 3 corresponds to this like minus 2x plus 3. We just factor out a negative 1 from these terms. Okay, so again, we have like a common term of like 2x plus 3. So we have a 2x times 2x plus 3, and then a minus 1 times 2x plus 3. So this is going to be equal to 3 times 2x minus 1, and then times 2x plus 3, just as we were doing before. And so now you just need to solve for these two linear equations, which we kind of already did for this one in the first example. Like we had a 2x minus 1. I'll just do it anyways. So we have that 2x minus 1 is going to be equal to 0. This is going to occur when we have that 2x is equal to 1. And if you divide both sides by 2, we have that x is going to be 1/2. This is exactly what we did for example 5. And then we have that 2x plus 3. You solve it in a similar way. So you subtract both sides by 3 to get that 2x is equal to negative 3. and then you divide both sides by 2 to get that x is going to be -3/2. So these are going to be the zeros. Oops. These are the zeros of f of x. Yeah, so this is really similar to what was done in example 5. Are there any questions about 1a or 1b? Okay. And it kind of looks like in the beginning that c is like similar to b in that you have like a coefficient to x squared that isn't equal to 1. But you can just factor out like a -1 for part c to make life easier. So this is the same thing as this having -1 times x squared minus 2x minus 15. And like the fact that we have a minus sign in front isn't going to change the zeros that we end up having for like x squared minus 2x minus 15. So I'd recommend like just factoring out the -1 and then just factoring what's inside the parentheses here. So you can see we have that -5 plus 3 is going to be equal to -2, which is this coefficient right here. And then we also have that -5 times 3 is equal to -15, which is this term, the constant term right here. And so what this is going to be equal to is this is just going to be equal to -1 times x minus 5, and then times x plus 3, like the two numbers we found that add into -2 and then multiply into -15. And so you see, like having the minus sign in front doesn't really change anything. Like 0 is going to be 0 regardless. Like you'll have like -1 times 0 instead. And so what this implies is that we have that f of x equals 0 at x is equal to 5. You plug in x is equal to 5 here, you have 0 times 5 plus 3, which is 0. And then we also have that f of x is going to be 0 at x is equal to -3 as well. So it's actually pretty much exactly like we did for A, except you just had to know to factor out like the minus sign in front. Any questions about C? Okay, and then D is kind of like A a little bit. You just have to know how to factor it. So how do you factor h of t in this situation? What is like the factorization of h of t here? I know some people have it. I walked around and people had it, so.
Just like t plus 8 times t plus 8.
Yeah, exactly. This is just going to be equal to t plus 8 squared. Maybe this is like redundant at this point, but we have like 8 plus 8 is equal to 16, which is like this coefficient of t. And then we also have that 8 times 8 is equal to 64, which is like the constant term right here. So it's like the exact same process we were doing for A and C. You just need to find these two numbers that kind of work out. And so what this implies is that the 0, so we have like h of t is going to end up being equal to 0 when we have that t is equal to -8. And so I guess this one's like a little bit unique, at least compared to like the previous three, in that we only have like one root right now, which is just like, well, I don't want to think like graphically yet, but you can kind of think like this is just going to be t squared shifted to the left 8 units. So kind of like the vertex is going to be on like the x-axis. I'm like talking graphically, which is like the next part of this worksheet. But, there's only like one root instead of like 2 roots. Any questions about this exercise before I move on? Okay. Yeah, and then this next, it's pretty quick. So we've been like finding zeros of quadratic equations algebraically, but you can also do it graphically as well. So pictured here is the graph of x squared minus 4. So this is just x squared shifted down 4 units, as we talked about earlier. And so for example 6, it wants you to find the zeros of x squared minus 4 algebraically and then graphically as well. So algebraically, it just means it wants you to solve the equation. Like it wants you to factor y is equal to x squared minus 4. And then graphically just is going to be just looking at the graph and seeing where our function ends up being equal to 0 pretty much. So first I'll just do things algebraically. And so this is what we've been doing so far. So algebraically, we have that y is equal to x squared minus 4. And this is just equal to x minus 2 times x plus 2. This is like an example we saw earlier. Like this is like a difference of square equation. So this is from like module like 1B. Like this is like way back. And so what this implies is we have that y is equal to 0 at x is equal to 2, and then x is equal to negative 2 as well. Corresponding to, so when x is equal to 2, like this linear component is 0, and then when x is equal to minus 2, this linear component is going to be equal to 0. And then graphically, so we know what the zeros are going to be. Like we know it's going to be 0 at x is equal to 2 and x is equal to minus 2. And so you can kind of see this is on the graph as well. So we see that the graph is going to intersect the x-axis at x is equal to negative 2 and x is equal to 2. And so when a graph intersects the x-axis, that means that its y value is going to be 0. So this is like the fact that it intersects the x-axis at x is equal to negative 2 and x is equal to 2 tells you that y is equal to 0 at those two values. I don't know like how to express that, but I guess maybe in terms of like graphically, just describing what I just said. We have that y intersects x-axis at x is equal to 2, and then x is equal to minus 2. So we have that y is equal to 0 at x is equal to 2, and then x is equal to minus 2. So that's like the gist of what's going on. You just need to find where the y or where your function intersects the x-axis, which is this point and this point. Okay, and then there's like a really quick exercise, like to finish the worksheet, which I'll give you just like a minute or two to work on, and then I'll quickly go over it. So you just need to see, I kind of already said it verbally, but I want you to fill in the blank, like the zeros of a function corresponding to blank is going to be represented by like what part of the graph pretty much. And then I want you to determine where some zeros are. So just spend like a minute or two on this next exercise, and then I'll just confirm your work pretty much, because I think most people understand this. Okay, so it seems like most people are getting these. So just to go through this. So just as I mentioned earlier, the zeros of a function are going to end up corresponding to the x-intercepts on the graph of the function. So this is just like, the x-intercept is just where y is equal to 0. Just like the y-intercept was where x was equal to 0. And so I'm just like going through a couple of examples. So we have that this is y is equal to minus 4x plus 3. What are the zeros of this function going to be? Yep, so we're just going to have x is equal to 1, and then x is equal to 3 are going to be zeros. It's where the graph intersects the x-axis right here. And then what are the zeros going to be of 2b? Yeah, exactly. So the zeros of b are going to be x is equal to -1, and then x is equal to 4 as well. So it corresponds to these values right here. So like the intersection with the x-axis. Okay, and then like the last question, I don't know exactly what they were going at with this one. I'm not gonna lie. But I think the point is that I think the main point they're trying to get at is there's like two intersections with the x-axis. So in other words, like these quadratic equations are going to have two roots when they're like above or below the x-axis. Because we saw earlier actually that they could have like a single root, except it has like multiplicity too. But for these ones, I guess like the important part is that they have two roots. Any questions about exercise 2? Okay, so again, it's a short worksheet, like there isn't really anything else. So you're free to go.
Oh my God, okay, I thought